Now we can use DMVs to monitor connections, and the DMVs used to monitor connections are the same ones that we would use to monitor connections with an on-premises instance of SQL Server. And these are sysdm exec connections, sysdm exec sessions, and sysdm exec requests. Now, along with DMVs, there are actually some dynamic management functions that we can use as well. The DMF sysdm exec SQL text is going to return the query text for a given SQL handle. Now, the query batch text column returns all the queries being sent as a request in one batch. So if we run the workload we ran earlier on, we will realize that the query batch text column contains all the queries specified in the workload SQL file. The running query text column returns the query which is currently being executed, and it is calculated using the statement offset start and end values from the sys.dm_exec_requests DMV. Now, there are some DMVs we can use to monitor performance. The following DMVs can be used to monitor queries and procedure performance. So we've got sys.dm_exec_query_stats. Now this DMV returns the aggregate statistics such as execution count, the number of reads, writes, and worker time for the cached query plans. The metrics available on the Azure portal can also be monitored using DMVs. And the first one we're going to look at is the sys_resource_stats. The sys.resource_stats DMV returns historical analysis for all the databases in an Azure SQL Server. The data is collected and aggregated every 5 minutes and retained for 2 weeks. Now, the following query here will return the resource utilization for the last 6 hours. So what you can see here, we're declaring a couple of variables and then we're doing a select statement. And we're getting database name, start and end time, average CPU %, average data IO %, average log write %, and we've got a subquery. We're getting the maximum from the values from the sys_resource_stats, where the database name is ToyStore and it's between the start and end time. Okay, so you can see there the start time is 3 hours ago. So I'm just going to highlight this and I'm going to execute my query. I'm going to let that run and it will return some results for us. So you can see there, you can see where we've had activity, we can see where we've had CPU usage or IO usage, writes and DTU usage too. Now over these last few here, CPU and data IO, I have been running my workload file. For the rest of the time there's been not a lot happening. So earlier on this morning there's not a lot happening, but for the last few minutes I had my workload running. Now the query underneath this one is going to return the average CPU utilization across databases. So this is going to help us identify the most used database. So it's just to select database name, the average of CPU % from our sys.resource_stats, grouping by database and then ordering by the average CPU %, putting the highest first. And if we execute that, you can see there split merge and then ToyStore are the most used. Now we can modify this query as well to return database exceeding certain thresholds. Say where the CPU utilization is greater than 80%. You can see there utilization in my particular case is minimal. Other useful DMVs include the sys.dm_db_resource_stats. Now this records data for individual Azure SQL databases and it records it every 15 seconds. It's retained for an hour. So this allows you to further drill down, further insight into database utilization. So the query we've got here returns the average CPU, data IO, log IO, and memory utilization for the ToyStore database. So if I execute this first one here against the ToyStore database, so notice there's a ToyStore at the top, it gives us the average CPU, average IO, average write, and average memory usage in percentage. The next query is going to return the average DTU utilization for the ToyStore database for the last hour. Now it happens I have had my workload running for a short amount of time during this period. So you can see there the average DTU went up when my workload was running, but it's been minimal for the rest of the time. We can use these dynamic management views to monitor connections, okay, And the DMVs used for monitoring connections in Azure are the same ones used to monitor connections with an on-premises SQL Server instance. And these are sysdm exec connections, sysdm exec sessions, and sysdm exec requests. So the query we have here returns all sessions for the login SQL admin. So I'll fire this up, and you can see there we've got 3-4 sessions coming from Management Studio and some information on those sessions. Then the query underneath returns all requests for the SQL admin login. So in this case, we're getting this information from the sysdm exec sessions joining on the sysdm exec requests, and then we're applying to the sysdm exec SQL text to return the SQL that's being returned. So I'm going to take this, I'm going to run it against the TyStore database, and we can see we've got session 100, and strangely enough, it's the query that I've just executed. Now there are some dynamic management functions, and in particular the sysdm exec SQL text, and this function returns the query text for a given SQL handle. The query batch text column returns all the queries being sent as a request in one batch. And if you run the workload that I mentioned earlier, which you can find on your code folder, you'll realize that the query batch column contains all the queries specified in that file. So the running query text column returns the query that's currently being executed and is calculated using the statement offset start and end values from the sysdm exec requests DMV. So the following query here we can use to monitor queries and procedure performance. Now the DMVs mentioned here are not specific to Azure SQL Database. They can be used on premises SQL Server instances as well. Now these are not only DMVs used to monitor performance. You can get a complete list of DMVs for Azure SQL Database from the Microsoft website. And you can also refer to a useful troubleshooting article for troubleshooting performance problems. There's some useful downloads on the Microsoft website as well. The troubleshooting performance problems is written for SQL Server 2008, however it applies to Azure SQL databases and later versions of SQL Server 2. Now the sysdm exec query stats DMV returns aggregated statistics such as the execution count, reads, writes and worker time for cached query plans. And the query we've got here is going to return the top CPU intensive queries. So in this case it's going to be the top 5 CPU intensive queries. And this is getting data from dmexec query stats, and we're cross-applying that to the dmexec SQL text. So if we execute that, you can see the results that we get back. Now, Glenn Berry, who's a Microsoft MVP, has compiled a list of DMV diagnostic queries. They're really useful. I suggest you head over to the SQL Skills website where you can download Glenn's diagnostic queries, but they are available in your code folder as well.